This circle is called the unit circle because its radius is 1 unit. And from this circle, a few observations, and we totally expand our whole understanding of trigonometry. So first of all, if we pick a random point on the circle, it would have an x-coordinate and a y-coordinate. So they've picked the point P in quadrant 1. It has an x-coordinate, it has a y-coordinate. If you then take that point and draw a line straight down, the height of a triangle that gets made would be y, and its base would be x. And it makes a right angle triangle. Now, what we're going to write on the next page is, from this circle, we can have 3 big ideas that are going to sort of be the important things for the rest of this unit. First of all, if you talked about the angle that was made here as theta, you've got a right angle triangle. You could say what sine of theta is. Sine of theta is the opposite side divided by the hypotenuse. And since it's a unit circle and the radius is 1, the opposite side is y, the hypotenuse is 1, well, that's just y. And if you did the same thing for cos, cos of theta would be adjacent side, which is x, over hypotenuse, which is 1, is just x. And tan of theta is the opposite side, y, divided by the adjacent side, x. That's just taking what you know about SOHCAHTOA and thinking about it. Now, the reason this gets a little bit crazy in math is because this point was x comma y. But now we can think of that point, instead of writing x, well, x is equal to cos of theta. And instead of writing y, y is equal to sine of theta. And this is going to be our first really big idea. That any point on the unit circle, instead of calling it x comma y, we can just use the angle and say cos of that angle, sine of that angle. The next thing that is really intriguing about drawing a triangle on a circle, which doesn't seem like that was so crazy, but it's a brilliant idea, is you know that a squared plus b squared equals c squared, right? In this equation, can you see that x squared plus y squared equals 1? In fact, that is the equation of any circle can be written this way. X squared plus y squared, since the radius is 1, it would be 1. If the radius was 2, it would be x squared plus y squared equals 4. And that makes an equation of any circle. If we turn our page, this is like the whole unit in a little tiny bit, so I'm a little bit excited about this. So we've got definition of cos is just x, definition of sine is just y, and definition of tan is y over x. Did I write that wrong? No, I didn't. Good. Okay. Some more definitions that they're going to introduce you to underneath are new trig functions. You've learned about sine, cos, and tan, and now you're going to get introduced to secant, cosecant, and cotangent. Now, all cosecant is 1 over sine, and all secant is 1 over cos. So off to the side here, I'm going to get you to write secant theta equals 1 over cos theta. And cosecant theta is equal to 1 over sine theta, and cotangent theta is 1 over tan theta. Can you see yourself screwing up the first two? But the tangent one is pretty easy. Cotangent goes with tangent. How am I ever going to remember that? Right? But cosecant, which starts with a C, goes with sine. And secant, which starts with an S, goes with cosine. And cosecant has like cos at the front of its word, but it doesn't go with cos. So it's like, oh. So those ones might be easy to mix up. So we're going to summarize, and you have space at the bottom of page 470. Is from that little triangle, we have the three big ideas of the unit. Three big ideas. Can't even underline big, it's too big. Okay, big idea number one. All points on the unit circle have the coordinates cos theta, comma sine theta. Instead of x, you have cos. Instead of y, you have sine. Big idea number two. If the equation of the circle, if you just do a squared plus b squared equals c squared, is x squared plus y squared equals 1, and x is cos and y is sine, then if we square cos and we square sine of any angle, we will always get 1. On your formula sheet, they give you it this way. Can you see that that's the same? Okay, sine squared plus cos squared equals 1. Now in math, when we square a trig function, we put the 2 in between cos and the angle. This means the whole thing squared. But it happens so much in math that mathematicians are like, oh, I hate writing all these brackets. Why don't we take the bracket away? And the problem with taking the bracket away, then another mathematician says, how do you know if it's the whole thing squared or just the theta squared? Oh, well then let's just move the 2 inside, and then we know the difference. If you want to square the theta, put the 2 outside. If you want to square the whole thing, put the 2 on the inside. So that's why this little 2 is in between the cos and the theta. So we don't have to write brackets every single time. That's big idea number 2. Okay? So now we can do some mental math. Right? Let's pick a random angle, 32 degrees. Okay, without your calculator, do sine of 32 degrees in your head. Remember about 8 decimal places. Got it? Good. Now take that 8 decimal place number and square it. Put it in a part of your memory that has room. Okay? Now we're going to take 32 degrees again. We're going to do cos of 32 degrees. Remember 8 decimal places. Okay? Good? Yeah? Now square that number. Good. Now you have that number. Bring that other one out from the memory we had before and add them up. What do you get? 1. See? You guys are awesome at mental math. Because it doesn't matter what angle you choose, as long as the angle, it has to be the same. But sine squared of 32 degrees plus cos squared of 32 degrees is going to equal 1. Pick 13 degrees, it's going to equal 1. Pick 5,682 degrees. Type it in your calculator, it's going to equal 1. Every single angle, when you do sine squared plus cos squared, if the angle is the same, will always equal to 1. That's big idea number 2. Now, big idea number 3. From that triangle, tan was y over x. But now, the y was sine. The x is cos. Did you know that if you take sine of 32 degrees and divide it by cos of 32 degrees, you get the exact same answers if you do tan of 32 degrees? That will always happen as well. That's big idea number 3. And so if you get stuck on a question in this unit, like I'm not quite sure how I'm going to solve this, often you just need to say, well, what were the 3 big ideas? And maybe one of those big ideas would help me. The most important one is the first one, that any point on the unit circle has these coordinates. And in fact, big idea number 1 explains the cast rule. If you think about it, here's your circle, pick a point in quadrant 1. Can you see that you would have a positive x coordinate and a positive y coordinate? Pick a point in quadrant 2, you would have a positive x coordinate but a negative y coordinate. No, I screwed up. You would have a negative x coordinate. There we go. Pick a point here. You would have a negative x coordinate but a positive y coordinate. Right? Cos is negative in quadrant 2. Sine is positive in quadrant 2. If you pick a point in quadrant 3, both the x coordinate and the y coordinate would be negative. And cos and sine are both negative in quadrant 3. And then in quadrant 4, well, your x coordinate would be positive, but your y coordinate would be negative. And cos is positive in quadrant 4, and sine is negative. And the cast rule is easily explained by big idea number 1. Whereas when you learned it at the beginning, it was just sort of like, well, we typed it into our calculator and found out it was negative, but we didn't know why. And so we just used the cast rule, but it was sort of like, I'm not sure why it comes. But it's all from big idea number 1. That if cos and sine are related to the coordinates, then we can tell where one is positive, where the other one is negative. And then if you use big idea number 3, you can figure out where tan is going to be positive. Because tan is just sine divided by cos. Well, positive divided by positive, positive divided by negative, negative divided by negative, negative divided by positive. You can see that tan would be positive in quadrant 3, but negative in 2 and 4.